Hello everybody, how's your summer going? In today's video, I'm going to be walking through my Rust setup for Advent of Code. Now, if you don't know what Advent of Code is, you can head over to adventofcode.com. It's basically an Advent calendar with 25 days, where each day has two sort of similar questions that you solve with programming. And it's an excellent way to learn a new programming language, so that's why I'm making this video to show you my process of setting up an Advent of Code project in Rust. So as you can see, if we click on a day, we'll get this day with a problem, and then we'll get a second part once you answer the first part. Now, if you come over here, you can see that we have puzzle input in the form of text. And this is basically what we're going to be running our code through. So let's get started. I'm going to make a new cargo project, and I'm just going to call it AOC for Advent of Code. If we come over here and we say cd AOC, we have this new Rust project that we can start out with. Now, I like this package called Anyhow that I'm going to add to this project, and it's just going to help us with error handling. So we're going to come to our cargo.toml, and we're going to say, we're going to say anyhow equals 1.0. And if we do a quick cargo build, it'll fetch that anyhow crate and it'll add it to our project. Great, now we can start working on our main file. If we just run it real quick, we can see it prints hello world as we expect, but I don't want this function to return void. I want it to return a result, which will make our lives easier when we end up having some errors. So let's say use anyhow result, and we're going to say our function main returns a result that's going to be void. Perfect. Now you'll see the compiler is screaming at us saying that we need to return something here, so we're going to return an OK value of void. Perfect. If we run this again, you can see it still prints hello world, and we can start on our input. So as you saw over here, we have days, 25 days, and each day has two parts. So let's grab the day from the user real quick. We're going to say let mute day, and day is going to be a string. And we're going to print. Now, no, I'm not using print line here, just simple print, because I want the user to enter the day on the same line. We're going to say print enter day. Right, and as you can see, if we run this, this day is going to be on its own line. We're going to import some quick standard tools. We're going to say use standard IO, and let's bring in standard in, standard out, and write. And we're going to need all three of these to get input from the user. First of all, we want to flush standard out. And the reason we want to do this is because, sorry, parentheses here. The reason we want to do this is because if we straight up read the user's input, it won't actually do the print statement. So we need the standard out.flush, and then we're going to do standard in.readLine. And we can just pass in a reference right here, but as you can see, the reference needs to be mutable. So let's do a quick mute right here, and now we have read our standard in. And again, this might error out, and you'll notice that on these two lines, I have a question mark at the end. This is because this flush and this read can error out and return a result, and that's why we have this anyhow crate, is that we can use this question mark operator and discard the error. So now we can say day equals day.trim. This removes the new line and any white space following the words, and we're going to say .parse, and we're going to parse this as an unsigned 8-bit integer. Now you might be wondering why we're not using an unsigned 32, and that's because there's only 25 days in Advent of Code, and that falls under the 255 limit for an unsigned 8. Right. So now let's quickly copy this, and let's read an integer for the part as well. So we're going to replace day with part. right? And now we have both the day and put, and then we can do a quick print line over here to see if we have everything working properly. If we run the program now, we can enter a day, like let's say 14, enter a part 2, and you can see it says day 14, part 2. Perfect. Now, how we're going to do the input is we're going to have a directory here. So right now I'm in the root directory. I'm going to make a directory called input in this root directory. And I'm going to copy and paste all of these input text files over into my input directory. And it's going to look something like input and the day. So it's going to be input day. And we're going to have a 2-digit number. So it's going to be like day 01, day 02, 03, etc. .txt. And that's going to be one of our input files for that day. Now you'll notice that each of these input files stays consistent throughout both parts of the day, so we will only need one input for each of the days. So let's read the input real quick. We're going to say input, and this is going to be a string. Input equals read to string. And let's use the input from standard FS. Again, we're going to format a string, and let's say ./input/day, and again we want the 02 here, and that's going to pad it with 10.txt, comma day. Perfect. Now, as you can see here, we have input, but you'll notice that it's a result of string and error, and we just want the string. So in the case that it's an error, let's do a quick match. And if it's okay, we want to just output okay again. But in the case that it's an error, right, we want to say that, or not print panic. Right, panic is going to just exit the program, and let's just say input file not found. Perfect. So now if we take a look at the type of input, it's going to be a string because we matched out that error case. Alright, now let's get into actually creating a solution. So I like to have a type for my solution so that it stays consistent across all days. So in our source directory, we're going to make a file called solution.rs, and let's come over to this file. We're going to have a part, which is going to be an individual part, like part 1 or part 2, part 1, part 2, and we're going to have a struct called solution, which is going to contain part 1 and part 2. So let's do a quick public type part, and this is going to be a it's going to be a function that takes in a string slice and returns out a string. So essentially, the string slice is going to be our input that we read from our input file, and the string is going to be our answer. After that, we want to have a public struct solution, and again, this is going to contain both parts of the day. So we're going to say pub part 1, and I actually like to make this an option because I might not have both parts done for the day, so I like to have the ability to either have a sum or a none for that part of the day. We're going to have an option of part, and then we're going to have a part 2, which is also going to be an option part. Now you'll notice that it says up here that the error is not showing, but this isn't included in our crate. So we actually need to come up to the top of main here and say pub mod solution to include it. You can see that error now goes away. Now that we have an error object, we can actually start making a day. So let's go over to source. We're going to make a days directory, and then under days, let's make a day01.rs. And this is going to be a day. Now the problem here is, again, you see it's not included in our crate hierarchy. So let's come back to days. Let's make a mod.rs file, and this is just going to expose all of our days into the crate. So let's say pub mod day01, and you'll notice that mod.rs isn't included either, so we need to come over to main and also say pub mod days. Perfect. And then now we have everything included, we can start working on a solution. For this example, I'm just going to reverse a string as our solution. So we're going to do a const part1, and you'll notice I'm doing a const because I want to be able to give it that type of a part from create solution part, and we're going to assign it the closure, which is going to take an input as an argument, and it's going to perform some action, right? And again, I want to just reverse this for a quick demonstration. So let's say input dot characters dot reverse dot collect, and let's collect this into a string. Perfect. Now, this is going to be our solution, and you're obviously going to have a more complicated solution, but just for this video, I'm going to do a string reversal. Now, we want to make a pub const solution, which is going to contain our solutions for this day. So again, we import solution from create solution, and then we're going to make a solution object where part1 is going to be a sum of part1, and then part2 is going to be none. Perfect. So as you can see now, we have the solution for day 1, and so far we've only made the solution of part 1, so we have some part 1 down here, which is awesome. So let's come back to main right here. We have the day, we have the part, we have the input. It's time to tie everything together now. We go to make a new line and say let solution, and this is sort of just going to pull the solution from that day. We're going to say equals match day, right? And if the day is 1, we're just going to return day's 1 solution. Pretty simple. And anything else, we have a nice Rust macro called unimplemented that we can just error out and say that, oh, we haven't implemented that day yet. Now that we have the solution, we can actually call the part. So we can say let answer equals match part. We only have 2 parts possible here, which is 1 and 2. So we can do 1 is going to be solution.part1. And then we're going to say 2 is going to be solution.part2. And then we're going to say anything else is unimplemented. Perfect. Now you'll notice that part 1 and part 2 are going to be sums, so we're going to have to unwrap them. And we're going to call .unwrap down here. And so far, everything right here is going to return a part, right? It's going to, this entire thing is going to be this type part we made up here. So finally, on this function, we're going to call it with a reference to input. And if we call everything like that, we should get an answer in the form of a string out of our part. So if we come down here, we can just say a quick println and print answer. Perfect. And if everything works correctly, we should be good to go. Now you'll notice if I do day 1 part 1, we get an input file not found. Now this is the error we made up here, which was if we don't have an input file, we're going to throw this error, we're going to panic called input file not found. So as a last thing, let's come over here. Let's go over to our input directory, and we're going to say day01.txt. And this is going to be our input for day number 1. Let's just add a string in here. And again, this string should be reversed when we call that day on here because our solution was to reverse the string. If we come back to main, we can do day 1, part 1, and as you can see, we get a reversed hello world out here. Now, that's all you need, but one final thing, just a cherry on top that I like, is to be able to actually see how long my solution takes, sort of a benchmark, right? So what I like to do is I like to come down here and say, let's start equals instant now. And this instant is going to be imported from standard time instant. And this is just going to be the instant we start the program, or start executing the solution. And then right after we get our answer, we're going to say let elapsed equals start.elapsed. So this elapsed variable is going to contain the time that it took for answer to calculate. So I'm just going to throw some quick print lines down here to separate our answer out, and I'm going to say print ln executed in, and I'm going to go out to 2 decimal places, question mark to format the elapsed time, and then put elapsed out here. So now if you see when I run the program, it'll actually tell me that this executed in 8.59 is that microseconds, I think, and it's just a nice way to see how long your solution takes, which I find quite nice. So yeah, that's it for how I set up my Rust project for this. If you have any questions, please feel free to leave them down in the comments below. I'm probably going to make a series on actually walking through all of these Advent of Code solutions because I find it really fun, and I'm going to do it in functional Rust. So stay tuned if you want to watch some of that and learn Rust along with me. And as always, thanks for watching, everyone. Hope you enjoyed the video, and I'll catch you in the next one. Peace.